Hello guys, welcome to today's video on Mathphile. In today's video, we're going to talk about integration. Our objectives for today is very simple. By the end of the lesson, you should know the power rule of integration and also appreciate the fact that integration is the direct opposite of differentiation. So let's dive into this video. I promise not to make this a longer video. I will do a lot of videos on integration, series of them actually, so just bear with me. This should be between 10 to 15 minutes so that you will be able to watch all at a sitting. Now, if this is the very first time visiting the channel, please subscribe to the channel and also share the video to someone that may need it. Let's get started. So integration. Earlier, I was saying that integration is the direct opposite of differentiation. Let's start everything from differentiating this function. Let's say 4x raised to the power 3. The process of differentiating this is actually pretty straightforward. There's a power rule of differentiation. What we normally do is to multiply the coefficients by the exponent, then we subtract 1 from the new exponent. So we then say that dy dx is going to be equal to multiply the 4 by the 3. So 4 times 3 x cubed. Then we subtract 1 from the exponent. So 4 times 3 is 12. Let me just write 12. Subtract 1 from the exponent, and this gives you 12x squared. So that's the differentiation. Integration basically will start from the 12x squared, and we work our way all the way to y is equal to 4x cubed. So with this one, if we're starting from 12x squared, in this stage we subtracted 1 from the exponent. So if we want to reverse everything, instead of subtracting 1, the reverse of subtraction is addition. So I'm going to add 1. This then simplifies to 12x cubed. Then from this stage, we realize that we multiplied by the exponent. So for you to reverse this, you need to divide by the exponent, since division is the opposite of multiplication. So I divide by the exponent. Now 12 divided by 3 gives you 4 and x cubed. So this is just going backwards to get the original function. So in simple terms, we say that to integrate a power function, we're going to add 1 to the exponent. So add 1 to the exponent, and the next stage we divide by the new exponent, and that differentiates the function. So we add 1 and we divide by the new exponent. So let's see if we can do some more. Okay, let's start with a simple function. We would start with a question and we integrate to see if we can get back the original function. So let's take 3x raised to the power 4. Well, we already did something like that. So 5x raised to the power 3 plus 8x squared plus 7x. So with this one, if you find dy dx, we can say that dy dx is going to be equal to 15x squared plus 16x plus 7. Let's assume that this aspect is not even there to work with. So let me just delete this one over there. Now, normally, the introductory part of integration, questions will be posed this way. Given that dy dx equal to whatever function, we'll be told to find y in terms of x, or just find y. So the solution process is straightforward. We realized previously that to undo the differentiation, we're going to add 1 to the exponent and divide by the new exponent. So that's how we're going to start off everything. We say that dy dx is equal to 15x squared plus 16x plus 7. We can now get rid of the denominator by multiplying everything by dx and multiplying the side by dx. This cancels out, leaving you with dy is equal to 15x squared plus 16x plus 7 dx. Now to get rid of differentiation, we integrate, And this is how the integral sign looks like. So the integral sign is basically like a stretched out s. So you stretch out the s, and that is the integral sign. You need to practice this for some time if this is your very first time writing the integral sign. So you're basically stretching out an s. So you can write this multiple times so that you get so used to it. So we integrate both sides, and this cancels out, and we get y to be equal to the integral of 15x squared plus 16x plus 7 dx. So with this one, to integrate, we realize that we need to add 1 to the exponent, so 2 plus 1, and divide by the new exponent, which is 2 plus 1. So plus 16 x raised to the power 1 plus 1, and divide by the new exponent, which is 1 plus 1. But with the 7 can be written as 7x raised to the power 0. So basically this becomes 7x raised to the power 0 plus 1 divided by 0 plus 1. So y is equal to this, and if you simplify this one, this should give you 15x cubed over 3. Then we've got 16x squared over 2, then 7x over 1, which after further simplification we should get y is equal to 5x cubed plus 8x squared plus 7x. And I'm very sure that is the function we started with. So this was the function we started with. So you can see that the integration actually reversed the differentiation. So initially I was writing a lot. We could actually skip this step and just jump into the fact that y is going to be equal to integral of the differential dx. So another way to look at this question would be, what are you to differentiate? Which function are you to differentiate to get what is inside the integration? Looking at it this way would save you a lot of trouble, especially with the integration. Yeah, I should also say that this integration is going to be restricted to additional mathematics for IG and O level. This is not going to cover integration techniques for A level. So if you are looking out for integration techniques for A level, I would produce different set of videos to cover that in no time. But for this set of videos I'm going to issue out, there will be strictly IG and O level additional mathematics integration. Okay, so what are you to integrate to get? What are you to differentiate to get whatever is inside the integration? So yeah, you can always check your answer and see if it's correct by differentiating your answer to see if you get whatever is inside the integration. So let's try one more. We take a question, set up the question, then we use the question to get an answer, and we integrate to see if we get our question back. So y is equal to 7x raised to the power 3 plus 8x squared plus 9x minus 3. Or let's not bring this one for now. Let's do one more with this one. So let's set up the question, given that y dx is equal to, if you differentiate this, you get 21x squared plus 16x plus 9. Find dy dx. So this is also something I would like you to do. You can pause the video over here and try to solve this by yourself and come back in about when you are done to check whether you are right or wrong. Another thing you can also do would be get a friend with you. Let your friend get a function, a normal polynomial function, differentiate that function, and use that differentiation to set up a question for you. So it should be like a fun little game, and see if you can reverse the differentiation. So this is just something you can do to practice. Okay, with that said, I should be done with the solution process by now. Let's see if we can solve this together. Okay, so we're going to start by saying that the function we're looking for is y, which is going to be the integral of 12x squared plus 16x plus 9 dx. So for you to integrate, it's simple. We add 1 to the exponent and divide by a new exponent. So 12 adding 1 to the exponents will make it 3 divided by 3 plus 16x. I think there's 21, not 12. Okay. Plus 16x, adding 1 to the exponent to be 2 divided by 2. And like I explained in the previous question, this 9 is the same as writing 9x raised to the power 0. So if you add 1 to 0, you get 1. So there's 9x raised to the power 1 divided by 1. So in this one, if you simplify, you should get y to be equal to this is 21, so let me 7x squared plus 8x 7x cubed. I have a lot of 7x cubed plus 8x squared plus 9x. So this was 21 and not 12. Okay, so that's the function we originally started with. You can see that is the function in blue, and that's the answer we got. So integration basically reverses everything that differentiation has done. So in some books you would see integration as the antiderivative or antiderivative. It depends on how you would pronounce it. So yeah, let's try more questions on this. Let's set up a question again. So y is equal to, this time let's say 15x squared plus, or let's say minus 3x plus 10. If you differentiate this, let's set up a question. So given that dy dx is equal to 15 times 2 is 30, so 30x minus 3. If you differentiate this is what you're going to get. Find y. So just set up a question for this. Let me move the solution upwards, so that the answer upwards, so that we get a solution to this. So we start off very simple. We say that y is equal to the integral of 30x minus 3 dx. So integrating this is simple. We add 1 to the exponent and divide by the new exponent. So this gives you 30x raised to the power 2 divided by 2 minus 3x raised to the power 0 plus 1, which is 1, divided by 1. This then gives you y is equal to 15x squared minus 3x. Now looking at this and comparing it to this one, we started with 15x squared minus 3x, but there is a problem over here. Even though integration kind of like reverses the differentiation, you could see that the answer we got over here in this case was very different. It's not that different. The only difference you can see would be this is having a 10 over here, but this is not having a 10 over here. That is because whenever you differentiate a function, the constant always goes to 0. So as a result, when you integrate a function, we always need to tell the examiner that even though this is looking like the answer, there is always a possibility of a constant that was differentiated that went to 0. So we are advised to add a plus c to this. This tells the examiner that we don't know that there is a constant attached to the function, original function, but there could be a possibility that there is a constant that was differentiated that went to 0. So we say that we add the plus c to it. So from now, anytime you integrate a function, an indefinite integral, I would explain the term and differentiate it very soon. Definite and indefinite integral. For now, if you integrate an indefinite, if you perform an indefinite integration, basically, you need to add a constant of integration c. So from now, anytime I integrate, I would add a constant c, and this tells the examiner that there could be a constant that was differentiated that went to 0, and integration won't be able to bring back that constant. So there will be some instances where you'll be given something called initial conditions and other things to find this constant of integration. But for the meantime, anytime you integrate, because there is a possibility of a loss of constant, we need to add the constant c to it. So in just a recap, we can say that if we've got y to be equal to integral of x raised to the power n dx, then if you integrate this one, it's very simple. We're going to add 1 to the exponent and divide by the new exponent, and not forgetting that there is always a possibility of a constant that may be missing due to the differentiation, so we add plus c to it. So that would be this, and we can add a little condition to it as well. So that little condition will be n should not be equal to -1. That will make the denominator 0. So that will be all for today's video. Like I said, I don't want it to go beyond 15 minutes. I want you to be able to watch all the video at one sitting. So if this video was helpful, don't forget to subscribe if you've not done that already, and share it to someone that you think would need it. Bye bye for now.